Welcome again to Nodes 2020. My name is Leila Bazuba, and I'm a research analyst at the University of Miami Sylvester Comprehensive Cancer Center. I'm one of the organizers of Our Ladies Miami, which is an international organization that is aimed at enabling gender equity among our community. It is my honor to present to you Véronique Gendner, where she will be presenting using Cypher to extend graph-based documentation. Véronique is currently on a one-year mission at the French National Institute of Geographical Information to consolidate different sources of geolocalized data and ontologies in a Neo4j database for the Shukas project. Véronique was born in France, but learned English to enhance her job prospects, and just out of passion, also learned Mandarin. She then learned natural language processing as a way to connect her verbal languages to computers, in which she started playing with at the age of 10. Many years in trying to write her PhD, when actually still playing with computers, she learned how to do a lot of data processing, writing Unix scripts, makefiles, regular expressions, and then an additional 10 years exploring the corporate world, where she got to do more data processing using tools like Excel and Visual Basic. It was from this she decided to build her own way of doing information design. For the past 5 years, she has been in the research field building web applications for data processing and information using MySQL, PHP, JavaScript, jQuery, CSS, and Bootstrap. She's been interested in graphs for at least 12 years and started seriously using Neo4j, Bloom, Link Curious at the beginning of 2020. Her personal research of using personal information systems like tools such as TheBrain, Evernote, Outlook, TikTok, InnoReader, Prezi, and their methodologies. So without further ado, I'd like to welcome Véronique Gendner.
Thank you. So using Cypher to extend a graph-based documentation. A lot of the presentation we see in this conference are about graphs for machines because they allow for better performances when you have to deal with huge amounts of data. They also allow to process data with graph data science algorithm. What I'd like to present is that graph can also be useful for humans. I think they're actually a new way of writing. With a pen and a paper, we were stuck at the tree level of complexity. It was difficult to represent information in a graph structure. But digital tools made this representation of graphs easy. It started out with hypertext, but I think graph databases and associated visualization tools are taking this writing in graphs to the next level. On the way, I will say a few words about information design. The way I understand it, that is, as a conceptual framework, I've built myself to work in the different fields I've been involved in. I will demo TheBrain technology, which is a documentation management tool, but as I'll explain why I see it as a writing tool to write the word in a graph structure. And then I'll show how with Cypher you can get more of the resulting graph structure with automatic processing. So information design, the way it's usually understood, is about visual representation. And I like to understand in all the different sense of representation. First, a database, for example, is also a representation. So I like to generalize to any kind of representation. And then representation means a human external document or database or whatever artifact we produce. But it's also our human internal way of dealing with the world, so our internal representation. And it's also the whole process between the two, producing a document or structuring a database is a whole process that starts out in our mind, right? In this sense, information design has to do with communication, with user interface and graphical interface issues. But even people who understand information design as centered on visual representation have to deal with structuring. And I like to include all the aspects of information structure in the scope of information design, because the way I see it, representation is a bit like the puppet that you can see, and the structure is like the string that makes the puppet move. So they're very, very much intertwined, and it's important to think of them in relation. So if you put structure into the picture, then you have everything that deals with modeling for databases, for applications. You have information architecture of website, architecture of information system. And then I also include in information design what concerns language, human language and formal language, because languages are the first way of connecting structure and representation. I'm using information design as I just described it in different fields. First, for document structuring, be it videos, text, new digital format. Then for database structuring, for web application creation. I think programming, script writing also involves some of the information design concept, because you have to think the flows of the information through the processing you build. You have to think about your data structure as well. And the last domain I use information design in is for my personal information system. This covers everything from email, documents, tasks, items on the calendar, and all these information are interrelated. For a specific task, you're probably going to need some specific documents. So I think we have a lot to gain to think of all these information as a system. And so the use case I will show you today is about the part of this system, which is about personal documentation. And when I say personal documentation, I mean the documentation you as a person build yourself, as opposed to the one a company or an institution will put together. And so it can be about your hobbies, it can be administrative documentation, you know, that paper you need to send the IRS before midnight and you cannot put your hands on. If you have a well-organized documentation, you're gonna save yourself the stress. And in this personal documentation, you can of course have professional information like reference documents about the languages the technical languages you use, or articles, or whatever is in the scope of your job. And this specific use case will be about a political social interest I have, that also part of my personal documentation. Here are the key concepts of information design that emerge from my experiences in the different fields I just mentioned. It's out of the scope of this talk to go into the details, but I will mention some of them in the example during the demos. So the use case. As a personal pro bono project, I'm writing a website to circulate information about different aspects of the situation of people who come to seek refuge in Europe and in France in particular. That's how I came across the situation of teenagers who end up arriving in France by themselves with no caring adult with them. By the law, they should be taken care of by the French administration. The least I can say is that it does not always happen in a satisfying way for the country that praised itself for the Declaration of Human Rights and who signed the Convention on the Right of the Child since they underage. So I decided to dig into the subject, try and understand how the administration and legal recourse are supposed to work, collect testimonies of these boys and of volunteers who take care of them, because otherwise they would just be left alone on the street. If you want to know more about the subject itself, you can check that URL. It's in French though. Okay, so the point here is the documentation, especially in the context of a subject I knew very little about at the beginning. It involves understanding details of how the administrative and judiciary systems work. Remember where the 100 French districts are located, most of which I've never been to, which is a challenge for my memory. So I have to build up a knowledge as I'm exploring the subject. At the beginning, I started collecting URLs of press article reports, and I had to organize them by theme. As the number of themes was growing, there was a need for structuring, but the structure of these organization had to be flexible, because as I was understanding step by step, I sometimes had to reorganize things. I also started filling Excel spreadsheet with list of people's contact, with list of NGOs with their website and contact, with list of press article by theme, with the name of the journalist, etc. So as it was growing, there was a need for more and more columns in the Excel spreadsheet. Some were relevant for only a couple of lines, and also all these information were interconnected. Press articles, for example, are connected to the journalist, but also to maybe the NGO that's mentioned in the article, and to people that might be in my contact list as well. So I either had to go for redundancy, or it was impossible to trace certain connection. And this is a typical use case for the brain technology. So here is how a documentation looks like in the brain technology. Information is organized in nodes and relationships. A node can be just text that you type in, and to a node you can attach a type, one and only one type. Types are visually identified by the color of text and optional icons. Since you build your own visualization, it helps you navigate in your documentation. Like, for example, I see that these are the important nodes because they're tagged with my important type here. So let's say, for example, this is going to be an argument. And you have one and only one type, but you can have as many tags. So typically I use them to mark documents I need to read, for people's profession, for the name of the media an article has been published in. So let's say let's put this one and this one. So tags are visible here. A node can also be a URL. If, for example, I found this report that I want to collect, I can just drag and drop the URL. And depending on how the title of the web page has been formatted, you get a more or less clean name for the node according to the title of the page. And let's say this is a report, so I can also just link a node to one of these specific nodes that are rounded because they are types. So attaching a node to a node type will set the type. Now, if I'm worried that the document might go offline, I can just download it and drag and drop it together with the URL on the same node or in a different node as you like, but I usually put them together. And so now with the proper setting here, you see what are the attachments to this node, and here you can write a comment. So just like you drag and drop URLs, you could also drag and drop an email from an Outlook item, for example, or any file format that you can put on a disk. And now it's organized in a graph, so I can connect this node to as many others I think it's related to, like, for example, the NGO that published it, and maybe I know it's about evaluation. I'm just gonna, so I link it to this team too. So this is for the main feature of the brain technology. The advantages I see is first that you have several search strategies. It's not just about collecting information, it's about finding it when you need it. And so having different search strategy is very useful. The first one is easy, it's just a search index. So if I want to see what I have about an exhibition, that's called stop. Kidding. I just type in a few characters and autocompletion comes on the thought names and on the notes and internal attachment here. So here is what I'm looking for, and I have the name of the photographer and all the information I have about this exhibition. The second strategy is by hopping from a node to another. Let's say I remember there is this documentary about football and a football team with these kids, but I can't remember the name of the documentary. I can just type in football, and here I go. This is the documentary I'm looking for. This way you can find what you're looking for by any related information. It can be a person, an institution, a conference, etc. The third strategy you could call fuzzy search. It's when you know what you're looking for is in a closed list. And so if you can come up with a small enough list, you can just go through each item and find what you're looking for. And so there are different ways of having lists in the brain. First, of course, are nodes. You have a list of other nodes beneath. And so if I remember, for example, a tweet with figures, I can search for the team figure. Well, I've been practicing so many times that now the tweet comes up first. But let's do it as if it wasn't there already. And so I can go to the theme and then go through the list of nodes under this theme, and I'll find that the tweet I'm looking for is here. Another way to get a list is with a type. Type and tags are just specific nodes, so you can navigate to a type just like this and have the list of all reports in the database. If I'm looking for an article that I remember was published by Le Telegram, I can type in, just go to the tag, and here are all articles I collected from this paper. And maybe if I don't find it, it's because it's a manually built documentation and I might have forgotten to tag the article when I collected it. So I can use reports and say, I want to look for URL attachment that contain this URL here. And I see that I indeed have more article from this paper. I just didn't properly type and tag them. So I'll probably find what I'm looking for here, and I can take the chance to complete my database and add the missing types and tags. We can also make a list by selecting nodes, or even, it's control-click, control-click to select. There are all other ways to select, but I'm not going into this detail now. This is another way to have a list, and then you can just go through the list, and as you check items out, you can control-click again until you're done. So several search strategies. Second thing is everything is centralized in one place. You don't have that question anymore. Where is it? Where is this information I'm looking for? Was it in an email, in a document that I will have in a directory, or is it in a bookmark? You have everything in the same place, no matter the format. And you're not going to miss important connections simply because there's no technical way to represent the connection. So we've seen how quick it is to capture information. So that gives you a very low collection cost, and collection cost is one of the main costs of information. That's the time you spend collecting it. Also, with the several search strategies I just mentioned, you have quick access to the place where the new information should be put. Because a lot of time, people lose the benefit of collecting information just because they don't spend enough time putting it at the right place so they find it when they need it. And so there's a virtuous circle, because the place is found quicker, so you're encouraged to put it at the right place. And that helps keep your documentation well organized, which in turn helps you find what you're looking for quicker. Another advantage is that you can have different information token size. If we go back to this figure 5, I could have whole reports, but they're 200 pages, and when I need a figure, I don't want to read 200 pages. So you can just extract a quote from a document and save it as a distinct node that you can attach to the article or the report, so you also have the source. And you can do that with text. You can also do that with a screen capture of something in the report. So you can put very large document or very fine-tuned information that still can be connected to the source it's been extracted from. Last advantage I want to mention is that the brain helps avoid duplicates. If, for example, I find this article I want to collect, it's telling me it's already in the brain, and I can just navigate to where it is. The other way it helps avoid duplicates is when you type the text for a node, there's a completion on all existing node, and so you can see when you don't need to create it because it's already there. So the brain is not just a digital document management tool. I think it's a graph writing tool. And I mean writing in the full sense. That is not just the document, it's not just about the document produced, but it's the whole associated cognitive process. It's supposed to be the natural way we internally represent ourselves the world, that is by association of idea. You have one idea related to different ideas that in turn are related to different other ideas, and that's a graph, right? And just like inner representation can be words, image, or sounds, here you can capture the information in the form it comes to your mind. You collect bits and pieces as they come, and then you organize those ideas as your understanding of the question builds up. Also, you might have experienced that when you write down your grocery list, then you don't need the list anymore because you remember what you need just because you wrote it. In a similar way, relating a new information to the current representation you have of a question is a new form of help for memorization and understanding. So just like writing, graph writing helps memorization, understanding, and elaborate your thought. It also helps connect the dot. First, because with a tool like TheBrain, you have a physical gesture to make the connection with a mouse, And we not only memorize and comprehend with images, pictures, and sound, but also with gesture. And having the possibility to physically represent this link, I think, has cognitive effects. Also because you have a visual feedback on this link you're creating. It also helps connect the dot in the sense that when you connect a node to another one, then all nodes associated with the second node will show up. And that's oftentimes when you go like, oh, right, this is also connected to that and that. I never thought of that. Finally, graph writing is a more adequate way to deal with categorization. We already talked about multi-categorization, but then there's also what back in the day when I was doing NLP, we called the tagger's paradox. And that is when you have a corporate tag, you're going to think of a set of tags first and then start tagging. But then you realize that items do not fit in the set of tags you thought of. So the paradox is you need a set of tags to start tagging, but you need to start tagging to figure an appropriate set of tags. The solution is an iterative process. That's why it's important that you have a tool that helps you change the categories and recategorize very easily. Graphs are a way to structure information in categories, but complete it as info comes in. Unlike tables, when you need to put the structure first, and you often end up with a lot of emptiness, here you can start out with a small category and then refine it as more items come in, or even just start out by collecting items that you sense are related, even if you don't really know the name of the category. And it's by looking at the items you put together that you're going to come up with the name of the category. Now, of course, graphs are not paradise. There are difficulties with graphs. The first is that we've been conditioned to structure ideas in hierarchies, like that is in a tree structure. At school, we learn to make a hierarchical plan for a document. And maybe more importantly, when you hop from a node to another, you can very easily get yourself trapped in an endless loop. There's no obvious way of order information in a graph. So I think it's important to learn how to deal with a graph structure, to come up with strategies to deal with these difficulties and train ourselves. Because let's not forget that a graph subsumes every basic formal structure we usually deal with. If you have different tables, it might be difficult to construct links between the different tables. But if you have a graph, you can always go back to a table, go back to a hierarchy. Of course, you have categorization. And as we've seen, you can also get back to a list. So an important feature of graph tools is the way they help us go back to this basic formal structure. We've already seen how the brain can get us back to a list. Let's just look at a way to go back to a hierarchy. As you might have noticed, there are two kinds of relationship here. There's the child-parent relation between the node in the center of the plex and its parents and children. And then there's what they call a jump relation at the brain, which allows to relate this node with any other node in the brain in a non-hierarchical way. And I think this is a very wise choice to keep both the hierarchical structure we're familiar with and still allow for the complexity of a graph structure. Also, in a node name, if you have a string that's separated with commas, like for example here, Utopia 56, if that string is in the name of the node in the center of the plex, it will not show in the related thought, so that your visualization is not clogged. But if you search in the instant search, here you will find the whole name. And I think this is a clever way of dealing with context, because in the plex here, you don't need the information because it's obvious that it's about Utopia 56 because of the context of the node in the center of the plex. In the instant search list, though, you need the information because there's no context. Now let's move on to what Neo4j can add to this. If you never heard of Neo4j, in the online presentation you'll find a couple of slides to introduce the subject, and in the dashboard below I put some resource I found useful as a newbie. So first thing you need to do is export the database from TheBrain. So in this database, for example, you have a couple of thousand nodes, and it takes a couple of minutes to export, just like this. But for the sake of this couple of minutes, I've done it already. Here it is. So you have a bunch of directories that contain attached documents. For now, I'm not using attached document. For now, I only use nodes, types and tags, relationships, and URL attached. To do the import, you need to put these JSON file in the Neo4j database import directory that you can access on the running database by this button here. We'll go right here, import, and for some reason it doesn't come up front, but it's here. And actually I've already copied the 3 files you need. So let's take a quick look at this .json file here. This is the one, typical JSON file with an item per node and a bunch of properties. So let's copy paste this Cypher in Neo4j browser. And the processing of links and attachment are going to take a little more time. So let me grab some code I'll need later on in the meantime. This is in my main documentation where I have cheat sheets for Cypher. This is what I'm looking for, because as we'll see in a moment, labels are created from the input text, and those names are accentuated characters, and something doesn't go very well with that. So the label have funny names. So until I figure how to fix this, I just replace the funny names by the proper label names. Okay, here we go. Let's go for this. And now let's take a look at the Cypher we just run. You can find the complete Cypher at that URL. So first thing, we just empty the database from the previous import. You will need the Epoch plugin, of course, to import files. And so actually the thought.json contains not only the thought, but also the types and tags. And types and tags are identified by this property. So a first read of the file extracts types and tags and creates node for each of them. And then a second read creates the thought themselves. And here is where you create a label with a thought type name. If there's no type for the node, then a thought label is created. So let's look at this node again, and let's see how it looks like in Neo4j. It's an NGO. The type NGO here is the label. This big pink node here is a tag, this one here. You see there's a geographical area attached and an email. This is the geographical area and here is the email. And you have two attachments, a Facebook page and the website that are here and there. Next come the links. This is for something I didn't show you, but in the brain you can actually name relationships. So the first read of links.json is to extract the named relationships. Like, this is how the JSON looks like. It's pretty straightforward. You have the IDs of the two thoughts you want to relate, and then a bunch of properties. Named relations are mixed into it with dummy IDs for the thought, and what you actually want to extract here is the ID of the relation and its name that's here. So basically the node you create here will only be used as a map between the ID and the name of the relationships. This is specific processing for relations between types and tags because they can also be structured together. But the core of relations are processed here. If it's a named relation, then you match the type we just created to get the name of the relation, and we create a relationship with that name. Otherwise, based on this property here, we determine if it's a children-parent type of relation or if it's a jump relation. And that's how we set a label for the relation we create. Attachments are very straightforward to import. You just match the thought it should be attached to by its ID, and then you create a link and another node with all the attachments properties. So here is the list of basic information in the brain and the list of basic information in Neo4j. And of course, there are different ways to map them together. I'm absolutely not saying the one I just showed is the best one. It's just the one I came up with for this experiment. And you probably want to try other maps because, as we know, modelization is very dependent on what you want to do with the data. So now that we have the data in Neo4j, what can we do with it? Let's say I need a list of NGOs with a localization, email address, Twitter account, Facebook page, and web page. All of this is in the properties of the node related to nodes labeled with this NGO label. So let's just go ahead and type this cipher in. In the brain, for geographical area, I have the number of the district, the name of the district, and the main city. Because as I said, there are 100 of them, and sometimes locals refer to them by their number, which doesn't mean anything to me. And so I want to be able to type just the number and see the name of the district and the main city name. But in the Neo4j database, I'd rather have these information separated as properties on the geographical node. So Here is the cipher. I need to cut this information into pieces. Here we go. And so now I can run this. So now I can run this cipher here. And here is my list with all the attached information. And now the sky is your limit, because you can have as many different projections as you need for different context of use. We've just extracted a table, but you can also have a hierarchy. Like, for example, for the website, I want a map with a list of local NGO for every district. And for this, I use AM charts, for which I need a JSON that looks like this. So let's go ahead and grab the cipher that allows to export for this. Here we go. So the only thing is, you can usually export here, but if I do so, I get an extra level of attribute that I don't need. So I just copy paste. So I just copy paste this display and add a comma here, and I'm done. And another thing you can take advantage of is that graphs allow to propagate information. Take this journalist, for example. I see I've collected 2 articles she wrote. An article are classified by subject. So now, what if I want a list of journalists with the list of the subject they're interested into? And this is it. It will be empty if I didn't tag the articles, but otherwise I get an idea of what the journalist is interested into. Finally, you can use Cypher to do automatic checks for the completeness and consistency of the data. Since it's a manually built database, there's a good chance some information is going to miss, or over the time I'm drifting away from my own rules. So the possibility to make some fine-tuned automatic checks is very useful. So for example, I can check if an article is a bit lost at the bottom of the graph with no connection to any geographical zone or any subject or anything that might draw my attention to it later on. So here's a list of such nodes, like for example, this one here, that is only attached to the author. So I probably want to attach it to the subject. Unfortunately, it's currently not possible to import a graph back into TheBrain. So this is the reason I made a distinct database for this subject, because my main documentation has now over 20,000 nodes and takes about an hour to export, when in this case, I need to be able to quickly export, import, and run Cypher queries, for example, to update the map of NGOs, or to do some manual corrections in TheBrain in an iterative way. When the brain technology started more than 20 years ago, there was no need for such an important feature because no one else was dealing with graph databases. Now, with all the graph databases technologies around, I do hope they will look into this because they did build a great user interface. So let's wrap up. This talk was a reminder that size don't matter. You don't need huge amounts of data to deal with and performance issues for a graph to be useful. I hope I've convinced you that it can be useful for humans too. The brain technology is not only a very efficient digital document management tool, but it's actually a way of writing a graph that you can see and manipulate with the mouse, which refers to the full sense of writing, that is about producing a human external representation, and also as a support for cognitive processes. Importing such a manually built graph-structured database in Neo4j allows for fine-tuned extraction of tables, hierarchies, or even other graph structure. It's also very useful for automatic checking of the completeness of the data, as well as the consistency and coherence of the structure. Along the way, I've exposed some of the key concepts for information design the way I see it, that is with a scope over representations, structure of information, and the way they're interrelated. I've been interested in graph structure for about 12 years, and I've seen digital tools that were offering the possibility for graph structuration of information back off to more hierarchical structure. So I'm wondering if writing in graph is just a personal preference not suited for everyone to deal with, or if we're just in the midst of an adaptation time to a new way of writing. Thank you for your attention.